Special relativity is a concept proposed by Albert Einstein in 1905, which has been used in many fields now, especially in astronomics, and is talked about in many different science fiction novels, and you've probably heard it used to relate to things like time travel and people staying young, and a lot of strange concepts, but I'm going to break it down to the two core postulates that it began with, and then I'll lead you to see why those other almost absurd results can be taken. So special relativity is really two postulates. The first one is having to do with inertial frames. So the basic idea is, say you are an observer standing on the ground, and you are doing any kind of action. Say you're jumping up and down and it involves a force on you, or say you are walking around, or you are holding some kind of mass or a stick, a meter stick, measuring your own height. These are actions that involve measurements. You're looking at your own mass, you're looking at your length, you're looking at your own velocity, your own force, etc. Now say you are the same person on some kind of moving platform, and you're doing all the same actions, but your entire reference frame is moving at a v separate to your own. We'll call this the v of the frame. So you are exactly the same person, but unbeknownst to you, your entire frame of reference is moving as well. So the basic idea is that, well, scientifically, we can't prove which one of these is actually moving, because the measurements should all be exactly the same within your reference point. So the first postulate of special relativity states that if you have one inertial reference frame, which means that all the laws of physics apply, and essentially that means that there's no acceleration on the frame. Then if you have a second reference frame, which has a velocity related to the first reference frame, then this is also an inertial frame, which means all the laws of physics apply in this own kind of its own world, its own reference frame. Now this seems very basic of an idea, except the biggest foundings of special relativity were that it actually does apply to speeds close to the speed of light, which brings us to our second postulate, is that speed of light is the same in all inertial frames. The big problem that led to this postulate was considering, let's say you are a rocket moving very close to the speed of light. Say your v is about 60% of the speed of light, and we usually define speed of light as c, which is 3 times 10 to the 8th meters per second. So you're going that quickly in this direction, and then say you saw a light beam headed in this direction. Well, how fast would that light appear to you to be going? Well, if it were less than light, that would be a huge contradiction of this first postulate, because it must appear the same in all inertial frames. Therefore, you're led to believe that even though you're moving this fast, the light is always moving at c relative to all inertial frames. This might seem extremely contradictory. Let's say you're almost catching up to the speed of light, and then a beam of light is shot from your own plane. It still moves at c. So once you accept this, which is experimentally proven, then you can begin to accept a lot of different strange, quirky things that happen in special relativity, like time dilation, length contraction, and so on.